Hello learners, welcome to part 2 of the chapter Electricity and Circuits. Hope you have enjoyed learning part 1, and in that part we learned about electric cell, different types of electric cells, electric bulb, and then the various ways of connecting electric bulb to an electric cell. Let's continue further, but before that, please like, subscribe and share the channel. It means a lot to me. A bulb connected to cell or cells. Let's extend the activity which we were doing in part 1. There we had a single cell connected to a bulb. But what happens when we have two cells connected one after the another? That means in series. And what happens when we have cells in parallel? Let's see both of the cases and also try to analyze the brightness of the bulb, whether it goes up or whether it remains the same as a single cell. So here we have two cells which are connected in series. The brightness of the bulb increases. That means the electricity generated by one cell is getting added to the electricity generated by the second cell, and that is giving more brightness to the bulb. Whereas when we have cells in parallel, the electricity being generated by each of the cells is not getting added up. And in that case, the brightness of the bulb remains the same. Undoubtedly, cells in parallel will be long lasting than a single cell. We have seen the arrangement of a bulb and a cell, which actually is an example of an electric circuit. Let's define electric circuit. Electric circuit is a continuous path through which electricity can flow between the two terminals of an electric cell. So here we have the diagram, which can be equivalently represented as this diagram, wherein cell and the bulb have their pictograms or symbolic representations. The positive of the cell is represented by the bigger bar and the negative by the shorter bar, whereas light bulb is represented by a circle with a cross in the center. Circuit can be open or closed. If it is a closed circuit, it allows continuous path for the electricity to flow. But if the circuit is open, it won't allow a continuous path for the electricity to flow. So either the positive may be connected and the negative disconnected, or positive disconnected and the negative connected. The bulb glows only when the electricity flows. That means the current flows through the circuit. Here are a few questions which I wanted to share at this point. The first question is, in which direction does the current flow? Since we have seen the circuit, now we want to find out the direction of the current. So put on your thinking caps and keep thinking. The direction of current is taken to be from the positive terminal to the negative terminal of the cell. So if we have this diagram, we have the positive over here and the negative over here. So this arrow and this arrow is actually representing the direction of flow of current. Second question. At times, despite the circuit being closed, why may not the bulb glow? Again, put on your thinking caps and keep thinking. It may happen if the bulb is fused. Now the question again, what makes bulb fuse? Again, put on your thinking caps. There are two reasons for it. Bulb may fuse due to, number one, shaking of the bulb, which results in filament breakage, and secondly, passage of more electricity than what the bulb can withstand. But how exactly does this fused bulb look like? Let's have a glimpse of a fused bulb with this picture. So we have the bulb which is intact and the second bulb is fused. Let me zoom it in. The filament, which is supported by two thick wires, has gone broken. This can be seen in this bigger picture. Electric switch. Our circuit diagram remains incomplete if there is no controller to the flow of electricity, which is a switch. Let's define switch and then we'll see how it controls the flow of electricity. Electric switch is a simple device which controls the flow of electric current through an electric circuit. It is also called key. A simple switch is shown in the diagram. It comprises drawing pins, safety pin, and wires. The arrangement is done on a cardboard or thermocol sheet. The two positions, open and closed, can be seen, which result in open circuit and closed circuit. And we know it very well. The bulb will glow only when the circuit is closed. We know about electric cell, electric bulb, and a switch. So it's a good time for us to discuss about an electric torch. An electric torch is a portable handheld electric light powered by one or more cells. Here we have a diagram of an electric torch which comprises electric cells, bulb, switch, and a reflector. If we turn the switch on, we have the bulb glowing. The red ant lines represent the path of the closed circuit. Now a science fact. Electric bulbs are being replaced by light emitting diodes or LEDs. They consume less energy, have a long life, and emit more light. Electric conductors and insulators. Before we dive into these two concepts, I have a question for you. If instead of wire, we use cotton thread to connect the components, will the bulb glow? Put on your thinking caps and keep thinking. Cotton thread won't allow electricity to pass, so the bulb won't glow. Here we have an activity. Let's find whether the objects used in the place of safety pin in the switch is a conductor or an insulator. Hope you remember this diagram of the switch. So here we have a table which actually has objects, material type, and whether the bulb glows or not. So we take the first object, which is toothpick. So if we place toothpick on point A and B, the bulb does not glow. If we put a nail, which is a metal, the bulb glows. If we put a scale, which is made of plastic, the bulb does not glow. If we put a key, which is made up of metal, the bulb glows. If we put a pen, which is made up of plastic, the bulb does not glow. If we put an eraser, it is rubber, which does not make the bulb glow. And lastly, if we put a paper strip, it also does not make the bulb glow. So we can conclude wood, plastic, rubber and paper do not conduct electricity, and that's the reason why the bulb is not glowing. Whereas the metal objects conduct electricity and make the bulb glow. Now we are positioned well to define conductors and insulators. So conductors, materials which allow electric current to flow through them. Example, all metals, alloys and graphite. Now graphite over here is an exception. Insulators, materials which do not allow electric current to flow through them. Example, wood, plastic, rubber. Here is another question for you. Which metals are the best conductors of electricity? So the metals which we have to choose from are copper, gold, aluminium, stainless steel and silver. Put on your thinking caps and keep thinking. So the answer is arranged in this pyramid format, wherein silver has the highest conductivity, followed by copper, aluminium, gold and stainless steel. In fact, in this entire group of metals, silver defines the conductivity, and all other metals are compared against it. On a scale of 0 to 100, silver ranks 100, with copper at 97 and gold at 76. Here we have an interesting add-on to the concepts which we have studied in this chapter. The first one is fuse. A safety device with a wire that melts and breaks an electric circuit if the current exceeds a safe level. Here we have a picture of a fuse which has that wire in the center. Here we have a second picture of blown fuse where the wire has broken off due to overheating. These days, instead of using a fuse, we have miniature circuit breakers or MCBs. MCB has a switch which trips off if there is overloading, and this switch can be brought into position once the circuit is corrected. Now a science fact. An electric circuit comprises electricity source, connecting wires, bulb or any other electrical device and switch. Next add-on is very closely related to electric circuit. Circuit diagram. A circuit diagram is a graphical representation of an electrical circuit. So here we have a diagram which has battery, switch and a light bulb, which are actually represented in their circuit symbols. Pictograms used to represent various electrical and electronic devices such as wires, batteries, resistors, etc. in the circuit diagram are called circuit symbols. Let's have few more of them. So we have switch which is open, we have switch which is closed, we have a cell with a big bar and a small bar, we have a lamp, we have a fuse, a voltmeter, battery which is an interconnection of cells arranged one after the other, diode, resistor, LED, emitter and LDR. Let's summarize the chapter. Electric cell is a source of electricity. It has two terminals, positive and negative. Electric cells are of two types, primary and secondary. Electric bulb has a filament connected to two terminals. Filament glows on the application of electricity. Electric circuit is a continuous path for the electricity to flow between two terminals of an electric cell. A closed circuit allows current to pass, whereas an open circuit does not allow. Switch is a simple device used to either break the circuit or to complete it. Materials which allow electric current to flow through them are called conductors. Materials which do not allow electric current to flow through them are called insulators. Here are the keywords used in the chapter. Conductors, materials or substances which allow electricity to flow through them. Electric bulb. An electric bulb is a device that produces visible light from electric current. Electric cell. An electric cell is a device which converts chemical energy into electrical energy. Electric circuit. An electric circuit is a path or line through which electricity can flow. Electricity. Electricity is fundamental form of energy observable in positive and negative forms that occur naturally as in lightning, or is produced as in a generator and is expressed in terms of the movement of electrons, charged particles. Filament. A conducting wire or thread with a high melting point forming part of an electric bulb which glows. Fuse. An electrical safety device that can stop current from flowing if it becomes overloaded. Insulators. Materials or substances which do not allow electricity to flow through them. Rechargeable. Of a storage cell or battery capable of being charged repeatedly. Switch. A device for making and breaking the connection in an electric circuit. As an extended learning to this chapter, find the different applications of electricity. How much electricity does an electric eel, which is a fish, produce? Make a presentation on the evolution of light bulbs over the years. You learned about conductors and insulators. Search and find semiconductors. Read about Benjamin Franklin, Alessandro Volta, Nikola Tesla, and Edison. Find which metal is used to make the filament for electric bulbs. Design a lemon battery to see if it can power a LED or small bulb. Make a project Shaky Hands. You will require a round hook, copper wire, cells, tape, bulb, side support, and wire. If while moving the hook from point A to B, the bulb glows, the person is out. With this, we come to an end of the chapter Electricity and Circuits. In case you have any query or questions, please write a mail to learning.space.mk@gmail.com. We'll meet again in the next chapter. Till then, happy learning!